Will SpaceX actually be the one to land NASA's astronauts on the moon later this decade? That's the big question, and lately it's gotten a lot more complicated. NASA's acting chief, Duffy, recently hinted that the agency might be rethinking its reliance on SpaceX for the upcoming lunar mission, exploring other options instead. The concern? Starship's hardware is still unproven, and that uncertainty could threaten the Artemis 3 timeline. Ironically, the alternatives NASA's considering aren't exactly flight-ready either. They come with their own technical risks, delays, and plenty of unknowns. So if untested hardware is really the problem, why not look to systems that are already proven, hardware that's reliable, cost-effective, and ready to fly? We're breaking it all down in today's Techmap episode. Alright, so here's the thing. The first crewed moon landing in over 50 years might not be SpaceX's big moment after all. Yeah, I know, that's a twist. Back in April 2021, NASA handed Elon Musk's company a massive $2.9 billion contract. The mission is to build the first crewed lunar lander for the Artemis program, and that lander isn't just any spacecraft. It's a tricked-out version of the upper stage from SpaceX's giant Starship rocket. The plan was for it to ferry astronauts down to the moon's surface on the upcoming Artemis 3 mission, but, well, NASA's getting a little impatient. They're not thrilled with how slowly Starship's been coming together, so they've decided to shake things up. According to Acting Agency Chief Duffy, NASA is reopening the competition for the Artemis 3 lunar lander, this time inviting 2 other contenders, Blue Origin and a more traditional cost-plus proposal from what you might call old space. Now, here's where it gets interesting. Elon Musk, who's all about competition, isn't exactly buying the idea that Blue Origin can ramp up fast enough to beat SpaceX to a crewed moon landing. And honestly, that skepticism kind of fits his style. You see, Blue Origin has never actually delivered a useful payload to orbit. Not once. The moon? Definitely not yet. Up to now, the company has only one orbital-class rocket, New Glenn, and that rocket finally took flight this past January, carrying a prototype of their Blue Ring spacecraft into Earth orbit. That was its first and so far only launch. Compare that to SpaceX, which has been launching orbital rockets for over 15 years, and, well, it's kind of hard to believe Blue Origin has the upper hand here. But here's where things get a little surprising. NASA's Duffy actually pointed to Blue Origin as a frontrunner. And no, not because of their complex Mark II lander, the one that, like Starship, needs orbital refueling. It's actually the simpler Blue Moon Mark I that's getting attention. Now, this smaller lander is still bigger than the old Apollo lunar module, but it doesn't rely on refueling. It's already deep in production and testing, with launches planned for early 2026 and 2027. Some experts think it could even be modified to carry a crew, which might fast-track America's return to the lunar surface. That said, if Blue Origin does upgrade the Mark I for a crewed Artemis 3 type mission, odds are it will still need some kind of orbital refueling. Makes sense, right? To land humans and bring them back safely, you need more propellant. So the team would either have to start from a higher Earth orbit to save on fuel or set up refueling between stages in space. And that's where Blue Origin's working on something called the Cislunar Transporter, basically a tug-and-tanker combo that can refuel their Blue Moon landers while orbiting the moon. Pretty wild. It's ambitious, cutting-edge stuff, just like what SpaceX is doing. But yeah, it's also really complex. The second option that NASA's Duffy mentioned involves a more traditional, government-led lander project, kind of an Apollo-style approach backed by companies like Lockheed Martin. Officials from those companies say they could build an Apollo lunar module-style lander in about 30 months. But here's the catch. That design was made for short lunar trips over 50 years ago, and it just doesn't line up with the complexity and long-term goals of the Artemis program today. Unlike the newer commercial contracts, This old-school, government-led setup would follow a cost-plus model. And that's expensive. We're talking about a lunar lander that could end up costing nearly 10 times what NASA awarded SpaceX back in 2021. On top of that, NASA can't exactly walk away from its existing contracts with SpaceX and Blue Origin. Especially in SpaceX's case, a lot of the funding has already gone out as milestone payments. So even if NASA tried to pivot, it would come with a massive price tag. In short, the cost of Artemis would skyrocket, and even then, it wouldn't guarantee a flawless mission. So some experts and members of the space community have been suggesting another path forward, one that could ease the complexity, shorten the schedule, and trim costs for Artemis. The idea is pretty simple. Use the hardware we already have, the stuff that's proven and ready to go. Think about it. There's a rocket out there that's long-range, relatively affordable, and seriously capable. It's past the development phase, it's flight-proven, and it's still flying missions today. That rocket is the Falcon Heavy. Until Blue Origin's system becomes operational, Falcon Heavy will be the only launcher in its class that's actually available. Maybe not the only super heavy rocket overall, but definitely the most practical option right now. It offers roughly half the payload capacity of the Saturn V and can send about 16.8 tons all the way to Mars. Not bad for a commercial vehicle. Many see Falcon Heavy as a powerful, cost-effective alternative to NASA's pricey SLS rocket, giving Artemis a way forward without breaking the budget. One possible scenario involves using Falcon Heavy to launch the Orion spacecraft into low Earth orbit. In the current Artemis 3 plan, Orion first reaches LEO, where the crew runs system checks and gets ready for the trans-lunar injection burn. Normally, the interim cold propulsion stage, or ICPS booster, handles that burn, pushing Orion toward the Moon. But with Falcon Heavy, the rocket could launch both Orion and ICPS together into Earth orbit. Performance-wise, Falcon Heavy can handle it. In its fully expendable configuration, it can lift up to 63,800 kilograms, about 140,000 pounds, to low Earth orbit. Meanwhile, the combined weight of Orion, the European Service Module, and the fully fueled ICPS is around 56,000 kilograms, or about 123,000 pounds. So the numbers work, and the capabilities are already there. In an alternative scenario where Falcon Heavy replaces the SLS, the overall mission profile would need some adjustments, maybe even dropping the ICPS booster altogether. By changing the flight plan, Falcon Heavy could potentially send Orion almost all the way to the Moon on its own. That approach would simplify things quite a bit. It would mean less integration work between Orion and Falcon Heavy, and it would eliminate the need for the ICPS, which isn't reusable anyway. According to SpaceX, Falcon Heavy can lift more than 26,300 kilograms to geosynchronous transfer orbit. From an energy standpoint, that orbit isn't far off from what's needed for a trans-lunar injection. The difference is only about 700 meters per second of delta V. That's where Orion's own propulsion system comes into play. The service module can provide up to 1.8 kilometers per second of delta V, which, at least on paper, would be enough to make up that shortfall and complete the push toward the Moon. There'd still be some fuel left for mid-course corrections, too. The trade-off is that Orion probably wouldn't have enough propellant left to enter lunar orbit once it got there. Instead, the spacecraft could take a free return trajectory, looping around the far side of the Moon and heading straight back to Earth. It's a smart, fuel-saving path that was actually used as a backup during the early Apollo missions. If something went wrong, that trajectory would let the crew coast safely back to Earth without needing another big engine burn after the trans-lunar injection. At this stage, one of the biggest hurdles is figuring out how to make two very different spacecraft work together: Falcon Heavy and Orion. To start, Orion would need a larger payload fairing to fit comfortably with all its components. Its launch abort system, which was designed specifically for the wider SLS core, would also have to be reworked to fit Falcon Heavy's slimmer frame. That alone would mean a lot of aerodynamic modeling, structural redesigns, and extensive testing. On top of that, engineers would need new structural adapters to safely connect everything together. And that's where an even bolder idea enters the conversation. What if Orion were replaced entirely by Crew Dragon? In that case, SpaceX could use its already operational Falcon Heavy to send a Dragon capsule into low lunar orbit, while another Falcon Heavy launches a separate lunar lander. Once both vehicles are in orbit around the Moon, the crew could transfer from Dragon to the lander for the descent. Of course, Dragon wasn't built for deep space travel. To make that work, it would need some major upgrades, starting with its re-entry and thermal protection systems to handle higher speeds and temperatures, plus life support improvements for a multi-day lunar trip. Its current communications setup depends on GPS, which doesn't function beyond Earth orbit, so a new deep space navigation and communication system would have to be installed. Then there's radiation. The deep space environment is far harsher than low Earth orbit, so while better shielding could protect the astronauts, the spacecraft's electronics would need to be hardened to survive. Finally, Crew Dragon doesn't have the delta V needed to enter and exit lunar orbit on its own. That means it would need an extra propulsion stage or some other method to give it the push to reach the Moon and the power to come back home. All of that might sound ambitious, but it's actually within reach. SpaceX has already floated a concept like this before, using their Crew Dragon spacecraft, launched by a Falcon Heavy, for a crewed trip around the Moon. It was pitched as an alternative approach to NASA's Artemis program, and the plan was surprisingly practical. Here's how it would work. First, a Falcon 9 rocket would launch Crew Dragon and its astronauts into low Earth orbit. Then, a Falcon Heavy would lift off separately, carrying its upper stage loaded with fuel. Once both vehicles were in orbit, Dragon would rendezvous and dock with the Falcon Heavy upper stage. From there, the upper stage would handle all the major burns, sending Crew Dragon on a path around the Moon and then back to Earth. Within that plan, there are two main variations. One uses just Crew Dragon and the Falcon Heavy upper stage to handle every key maneuver: the trans-lunar injection, lunar orbit capture, and the return burn. The other option adds a smaller propulsion stage launched alongside Falcon Heavy, which would take over for the lunar orbit insertion and Earth return phases.
Remember, SpaceX once worked on a project called Red Dragon, a spacecraft concept designed for deep space missions. Given SpaceX's experience with Red Dragon and their ongoing progress with Starship, it's not impossible to imagine them creating a smaller, specialized lunar lander inspired by that design. Such a vehicle could take lessons from Red Dragon's approach to entry, descent, and landing, but be optimized for the Moon's unique gravity and terrain. Here's the difference. The Dragon spacecraft is smaller and simpler than Starship. Because of its size and purpose, Starship has to handle landing and taking off on the Moon while carrying heavy payloads, a major engineering challenge. A smaller capsule-style lander would be easier to design for that job, but it wouldn't be as versatile. Starship, on the other hand, is being built for multiple missions, including future Mars landings. That flexibility makes it powerful, but also makes its development a lot more complex and time-consuming. So maybe Dragon could be the short-term solution for lunar missions. And honestly, that wouldn't be a huge problem for SpaceX, since Elon Musk's main focus has always been Mars, not the Moon. Think about it. The Dragon spacecraft has already proven itself by flying missions to low Earth orbit. Adapting it for the Moon would likely be less complicated than developing a brand new, massive rocket like Starship HLS from scratch. By using existing hardware and technology, SpaceX could save a lot of time, money, and testing. That means lower costs and fewer risks overall. And Dragon's track record speaks for itself. Since its first crewed flight in 2020, it has completed 11 successful official missions for NASA, safely carrying astronauts to and from the International Space Station. On top of that, it's also been part of some groundbreaking private missions, like Polaris Dawn, which reached the highest Earth orbit since the Apollo program, and Fram 2, the first ever human spaceflight to circle Earth over its poles. With that kind of performance, it's fair to say Dragon has already pushed the limits of what's possible in Earth orbit. So, could it handle a lunar mission? Honestly, it doesn't seem too far-fetched. The real question now is, does NASA actually want to support SpaceX developing a lunar version of Dragon? If that ever happens, Dragon could even replace NASA's Orion spacecraft. And honestly, that wouldn't be surprising. Dragon is not just cheaper than Orion. It is much better because it is much lighter. This spacecraft weighs about 9.5 tons, while Orion comes in at around 26.5 tons, almost 3 times heavier. Orion's weight could have been reduced, but over the years NASA has faced a lot of conflicting goals and political pressure from different administrations. That made the spacecraft more complex and heavier than it probably needed to be. Dragon only weighs about 20% more than the old Apollo capsule, yet it offers 50% more internal space, so it's still roomy enough for its crew. Dragon's lighter design makes it easier and cheaper to launch, and the best part is, it doesn't need NASA's expensive SLS rocket to get to the moon. Instead, we could use SpaceX's Falcon Heavy, a rocket that's already flying and proven reliable. That means no waiting years for new hardware or spending billions more on launches. Now, it's true that Falcon Heavy isn't officially human-rated, meaning it's not yet approved to carry astronauts, but technically it could be. Just like its smaller counterpart, the Falcon 9, Falcon Heavy could be modified to safely carry people if it were equipped with the right life support systems and safety features. These upgrades would include things like enhanced avionics, an emergency abort system, and better crew evacuation capabilities. SpaceX has already proven it can build safe, crew-capable systems with the Crew Dragon spacecraft, which regularly launches astronauts to the ISS on Falcon 9 rockets. So applying similar safety standards to Falcon Heavy is definitely within reach from a technical standpoint. In fact, SpaceX has shown interest in using Falcon Heavy for crewed lunar missions. NASA's HLS discussions have even included Falcon Heavy variants as possible launch options. On paper, a Falcon Heavy launch has the power to lift NASA's Orion spacecraft and its European service module into Earth orbit, which is the first major step for any lunar mission. Some mission concepts even suggest using Falcon Heavy to launch Crew Dragon into Earth orbit, where it would rendezvous with a separate lunar lander, like Starship, already waiting near the moon. The astronauts would transfer from Dragon into Starship, which would then fire its engines to leave Earth's orbit and head toward the moon. To put the scale in perspective, Crew Dragon is about 8 meters tall and 4 meters wide, roughly the size of a small delivery truck. Starship, on the other hand, is a giant, standing at around 50 meters tall with a 9-meter diameter. It's so enormous that it could literally fit several Crew Dragons inside its cargo bay. However, human-rating Falcon Heavy wouldn't be easy or cheap. It would also take major upgrades and modifications to the Dragon spacecraft to handle longer, deeper space missions. Meanwhile, NASA designed the SLS rocket and Orion capsule specifically for human spaceflight, with safety as the top priority. They have lots of safety features that have been tested and proven to work for sending astronauts to the moon and back. Changing to a new system takes time and many tests to make sure it is just as safe. Therefore, convincing NASA and Congress to phase out SLS and Orion and replace them right away with SpaceX's private vehicles isn't as easy as it sounds. Additionally, both SLS and Orion were built using government funding and have strong congressional backing. These programs support thousands of jobs across multiple states and involve dozens of contractors and suppliers. That means a lot of political and economic interests are tied to keeping them alive. Cutting SLS and Orion wouldn't just end a space program, it would also impact local economies and workers in those regions. So, naturally, many lawmakers fight to keep the funding flowing. Next, there's the issue of different goals and backup plans. NASA doesn't want to rely on just one company or one system to send astronauts to the moon. Having multiple options adds redundancy, basically a backup plan in case something goes wrong. That's why NASA continues to invest in both its own systems, like SLS and Orion, and private options like SpaceX's Starship. In other words, this isn't just about technology. It's about politics, jobs, and strategy. NASA wants to make sure the U.S. has more than one reliable way to get astronauts to the moon and beyond, even if that means sticking with some older, more expensive programs a bit longer. Anyway, despite all the technical and political challenges, the idea of using low-cost private vehicles like SpaceX's Dragon and Falcon Heavy could be a much more practical and affordable alternative to NASA's current and extremely expensive Artemis structure. When we look deeper into one of NASA's most ambitious and controversial efforts, it's impossible not to talk about the infamous duo, the SLS rocket and the Orion spacecraft. And trust me, the numbers behind them are shocking. Let's start with SLS. So far, its development has cost around $24 billion. And get this, each launch costs about $4 billion. That's right, one launch. But it doesn't stop there. The infrastructure that supports SLS, like the Mobile Launcher 2, has faced massive delays and budget overruns. That single project could end up costing around $2.7 billion, far beyond its original budget. Now, let's talk about Orion, because things aren't looking much better there. The spacecraft has already piled up around $20 billion in cost overruns, with ongoing technical problems ranging from life support system issues to heat shield failures.